let's look at a standard pack of our cards. Now guys, tell me, how many cards are there in a standard pack? You guys should remember that it's 52 in total. I've got a little diagram for you over here. These are the total cards in a pack, and as I said, it's 52 cards in a standard pack. Now, 52 does not include jokers. So for those who are wondering if jokers included, we never really include the jokers in these probability questions, so trying to exclude those away. And excluding the jokers is 52. Now, as you can see on the board, in colours, there's two different colours. There's red or black usually, so there's always two different colours. And let's discuss about how many different types we have. First of all, what types of sweets do we have? The shapes. It's going to be 4 different types. As you can see here, we've got heart club, spade, and we've also got a diamond. So those 4 types. And how many different letter cards do we have? We've got A, J, Q, and K. K for king, Q for queen, and J for jack. Now, these are also called court cards, the jack, queen, king. So trying to remember them as court cards as well. And for the numbers, we have starting from 2. We don't start from 1, we start from 2, and we go all the way to 10. Alright guys, so try to remember that for me. And as we go through the questions, you'll get a bit more of an idea of what these cards are meaning. So, let's go straight into it. We'll go starting with question 1. It says, how many outcomes are there in a sample space? Are in the sample space. So the sample space is all the possible outcomes that we have. So every single individual card is different, guys. They have different shapes, or sweets if you like to call it. They have different numbers, colors, and everything. So altogether there's 52 different outcomes. Every single card are unique on its own, so every single one is a different outcome. Alright guys, so 52 numbers of cards in the sample space. Now let's go to question 2. It says, are each outcome equally likely? Is each outcome equally likely? Well, each outcome is individual of their own, and each of them is only one of each. So, yes, they are equally likely. There's only one of each unique card. Alright guys? So, let's move on to question 3. How many aces? How many are aces, guys? Now, aces is the letters of A, so those ones. And we have exactly 1, 2, 3, 4. So 4 of them are aces. Now if we go to the next one, how many are sevens? Now sevens, these are the sevens. And you can see that there's 4 of them. Yes? 4 sevens, 1, 2, 3, 4. So 4 sevens. Now let's look at the question 5. How many hearts? Now heart is one of a sweet. So all of this is a heart. So if you count all of those up for me, you'll see that there's 13. Yes? 13 of them are hearts. Now, let's have a look at the next one. How many are red 9s? Now, we know that there's 4 9s. There's 4 of each type, isn't it? But we just want specifically the red 9s. So, only these are the red 9s. The other 2 are black, so we don't include them. So, it's just the red ones. So, there's only 2 of the red 9s. Make sense, guys? So, make sure you can count them very nicely. Alright, let's look at the next one. How many picture cards? Now, picture cards are the ones that have the pictures on them. Now, by the pictures, I don't really mean the shapes or the sweets. It's these particular ones. See how they all have different unique pictures? These are the picture cards. So if you count them all, there's 4 by 3, which makes 12. Alright guys, so these are the picture cards, and you can know them as the Jack, Queen, Kings. Those are the picture cards. So trying to remember that for me. Alright, the next one. Okay, how many black kings? Now the kings are the ones with the letter K in them, but we want specifically the black ones. So it must be just those 2. The other 2 are red, so we just want the black ones. Must be 2 of them. Now, the next one. This time we want to find the probability. You guys have seen this notation before. The P with the bracket means a probability. It's a notation for a probability of the jack. So what you focus on what's inside the brackets. So, guys, if we have to look at probability, we have to first know how many jacks there are. See, these are the jacks, and they start with the letter J, so that will be easy for you. So 4 of them are jacks, isn't it? But with probability, we always have to put that outcome over the total number of outcomes. So we know that there's 52 outcomes in this sample space. So for jacks, there's only 4 of them. So 4 out of 52 is our probability. But don't forget to simplify them. You always have to simplify your probability. So I can see that 4 and 52 has common factors of 4. That's the highest common factor that we have. So Let's simplify it, guys. Let's cross out the 4, that just becomes 1. 4 divided by 4 is 1. And let's cross out the 52, and it will become 13. So this final probability is 1 over 13. Simplified form, isn't it? So make sure you do that. Alright, let's look at the next one. Find the probability of a 5. Now 5 means the number 5. How many number 5s do we have in our card pack? There's 4 of them. 4 of them are 5s. So 4 of them are 5, and because we're looking for probability, always put it over the total number of outcomes. The total number of outcomes, we all know that is 52. So it's 4 out of 52. It's pretty much exactly the same as the previous one, isn't it? So again, the common factor is going to be 4. Let's cross it out. That becomes 1. Let's cross out 52. It becomes a 13. So it becomes 1 over 13 again. So it's exactly the same, yes, as the question that we did prior to this question. Because the number of 5s is same as the number of jacks. It must have the same probability, isn't it? So you guys want to keep in mind that every single different type, there's equal numbers. So there's 4 5s, 4 jacks, and 4 7s, 4 2s. You guys kind of remember that for future reference. So if you look at the next one, this time it says find the probability of a diamond. Now diamond is one of the sweets, the shapes, isn't it? So all of this whole lot is diamonds, yeah? So if you count them up, you'll see that there's 13. And because we're looking for probability, don't forget to put it over 52. Make sure you don't just say 13. So it's 13 out of 52. Now 13 and 52, if you could find the common factor, the highest common factor, it's probably 13. So I'm going to cross out the 13, it just goes away. It becomes a 1 actually. The 52 let's cross out and it becomes 4. 52 divided by 13 is 4. So we basically have a final probability of 1 over 4. Now 1 over 4 is a quarter, and you can clearly see that diamond is quarter of all the outcomes. So if I want the probability in your heart, it would also be quarter. You can remember that because we have equal numbers of different sweets, you have to remember that each one of them is a quarter of a total number of outcomes. So that's a quarter. Let's look at the next one. It's the probability of black. Now, remember guys, these are black, these are red. I kind of colored them in for you. So if you can count the blacks, those are the ones. Count them up, guys. Probably realize that there's 26 of them. And again, because we're doing probability, let's put it over 52. So there's 26 out of 52. And guys, 26 and 52, 26 is the most highest common factor. So let's cross out the 26, it just becomes 1. And let's cross out the 52, and 52 divided by 26 is 2. So we basically have 1 over 2 left, which is our final probability, which is basically half. And you can probably just go straight to half just by looking at the diagram. Half is black, half of red. So that was quite an easy one. You didn't even need to maybe write this. You can maybe go straight to half if you know that half are black and half are red. Alright, the next one. We want to find the probability of red ace. Now, ace are the cards with the letter A in them. Now, we want specifically the red ace. So, we just want those two. See? These two are red, the other two are black. So make sure you don't include the black ones. We're just looking at the red ones. And you can see that there's clearly 2. So it's 2 out of the 52. Let's just simplify it by 2. Let's divide top and bottom by 2. The 2 will cross out. The 52 will cross out. And 52 divided by 2 is 26. 1 over 26 is our final probability of a red ace. Make sense, guys? So always look for simplification. You have to simplify it to get your full marks. Alright, let's look at the next one. Question 14. Find the probability of a picture card. So remember what I said earlier? I did mention this before. What's a picture card? Picture cards are those with the pictures on them. But again, make sure you don't get confused with pictures. It doesn't mean the shapes. It actually means these ones over here that have the little complicated pictures on them. It's got Jack, Queen, King on them. So those are the picture cards. And we've got 4 jacks, 4 queens, 4 kings. So altogether we have 12 picture cards. So it's 12 out of the 52. And we can simplify. Let's cross the 12 out because I know that 12 and 52 have a common factor of 4. So 12 divided by 4 is 3. Let's cross out the 52. And 52 divided by 4 will give us 13. So our final probability is 3 over 13. And we can't go any further. So that will be your final one. Alright guys, so that's the probability of a picture card. Let's move on. Question 15. Find the probability of red queen. So remember the queens are the ones with the alphabet Q in them. These ones over here. But we specifically want the red ones. So if you highlight the red ones or circle them or put the box around them like me, those are the red ones, and it's clearly just 2 because the other 2 are black. So we just want the 2 red ones. So it's going to be 2 out of the 52. Again, let's simplify. You guys should be good at the simplification by now. Let's cross out the 2, just becomes 1. I'm just going to divide it by 2. So 2 divided by 2 is 1. 52 divided by 2 is 26. We simply have 1 over 26 left. Alright guys, so that's it. We can't do any further. That's the probability of a red queen. Now let's do another one, guys. It says find the probability of a letter card. So letter. So this is very simple. Just find the cards that has a letter on them. It's these ones, Jack, Queen, King, and of course the Ace. So they all have the letters on them. So we did it earlier that there's 4 Jacks, 4 Queens, 4 Kings, and there's also 4 Ace. So we have to multiply 4 by 4, which is 16. So 16 over 52. If you count them all up, there should be 16 out of the total of 52. And let's simplify again. Let's cross out the 16 and it becomes a 4. I'm basically dividing by 4 because I know that 16 and 52 are divisible by 4. That's probably the highest common factor. And 52, let's cross it out. 52 divided by 4 is 13. So finally what we have is 4 over 13. That's our final probability of a letter card.